Well, we're working on identifying parallel lines, and we've got several postulates and theorems that we can use to help us identify parallel lines. We got the converse of the corresponding angles postulate. And let's see, that says that if two lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. There's a parallel postulate. We have an alternate exterior angles converse theorem. We've got a consecutive interior angles converse theorem, an alternate interior angles converse theorem, and then there's a perpendicular transversal converse. And we'll talk about those a little bit more as we work through some of these exercises. Now, this is coming from example 1 on page 208 and then continues over to page 209, top of page 209. So you should be there in your textbooks. And let's see, it says, given the following information, and that's our diagram over here, determine which lines, if any, are parallel, and then state the postulate or theorem that justifies your answer. And the first up is measure of angle 2 is congruent to the measure of angle 8. So we're told that the measure of angle 2 is congruent to the measure of angle 8. Let's find angle 2. So angle 2 is right here, and angle 8 is right here. All right, so then I got to think, okay, what two lines might be parallel, and very importantly, which line is the transversal that is cutting between these two parallel lines. And sometimes I might have to twist the book around, twist the paper around, twist my head around, or I could rotate this object if I had it digitally. But when looking at angle 2 and angle 8, which I've been told that they're measures that they are congruent, then it would appear that they're both in the interior of this line A and this line B. And if that's the case, then my transversal is line L. So now I got a transversal line A, and I'm looking at A and B to determine if they're parallel. And I know that the measure of angle 2 and the measure of angle 8 are congruent. And so then what theorem or postulate could I use to prove that A is parallel to B, which looks like is my potential two parallel lines? Well, if I look at that, angle 2 and angle 8 are both in the interior of lines A and B, and they're on opposite sides of the transversal L. And so we could then say that we can prove this parallel by the alternate interior, and I'm abbreviating here, angles converse. Okay, so I got to identify which lines might be parallel. I got to identify what would be the transversal after I have identified which angles I'm looking at to determine if we can use a theorem or postulate to prove that those lines are parallel. I'm going to look at some more. All right, well, this time we're told that the measure of angle 3 and the measure of angle 11, that they are congruent. So let's see, I want to identify, here's angle 3, and here's angle 11. All right, so if I'm looking at 3 and 11, which two lines might I be considering that are parallel? And where is the transversal? Well, if A is the transversal, that's the transversal, then the two lines that might be parallel are L and M. All right, so then we got that knocked out of the way. Now I've got to consider, okay, well, if the measure of angle 3 and the measure of angle 11, if they are congruent, what angle relationship exists between 3 and 11 if L and M are parallel and line A, is the transversal? Well, they're on the same side of the transversal, and one's in the interior, one's in the exterior. So let's see, we could say then that L is parallel to M by using, because 3 and 11 would be converse, they'd be corresponding angles, right? They'd be corresponding angles. And so L is parallel to M by the converse of the corresponding angles postulate. What does that converse of corresponding angles postulate say? If two lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. All right, Shazam. Okay, let's see. Now we're looking at, let me change colors here. We're looking at the measure of angle 12 and the measure of angle 14. 12 and 14. All right, here's 12. Ooh, and here's 14 way over here. All right, so again, I'm going to probably have to twist my head around here and think about where these angles are. What might be the transversal? All right, I think that if line M is the transversal, and it's cutting between A and B, so I'm thinking maybe A and B are the parallel lines, that line M is the transversal of those two parallel lines. And then what would be the angle relationship? They're on opposite sides of the transversal M. They are both on the exterior of the two parallel lines. All right, I'm getting there. So let's see. A is parallel to B, and I'm doing that by the, what would that be? What would that be? Well, if they're on the opposite sides of the transversal and both of them are exterior to the two parallel lines, A and B, then I'm proving that by the alternate exterior angles theorem. And let's review what that alternate exterior angle, it's the converse of that too. I better put converse in there, won't be right. Yeah, converse. It's the converse of that theorem. Let's see, what does that say? Alternate exterior angles converse. If two lines in a plane are cut by a transversal, okay, my transversal is M, so that a pair of alternate exterior angles is congruent, then the lines are parallel. A and B would be parallel based upon the alternate exterior angles theorem converse. We're still going to look at a couple more. Okay, let's see. Let's look at angle 1 and angle 15. Here's angle 1 up here. There's angle 15 down here. Well, if I'm thinking, well, let's see, what if it is L and M, if I'm thinking L and M is parallel, but what would my transversal be? What about if I'm looking at lines A and B? If A and B would parallel, if this transversal L here, if I'm looking at it, well, that would be that set of angles right there would have angle relationships. And if M is the transversal of A and B, well, then it's this set of angles down here. And I just don't have any angle pair relationships that would justify that. Let me look at L and M again. If L and M, let me put this in a slightly different color. If I'm thinking L and M is parallel, then this if and A was the transversal, that'd be that set of angles. Well, that doesn't include 1 and 15. And if I'm looking at L and M are parallel and B is the transversal, that's that set of angles. And angle 1 and angle 15 just don't match up to any situation that I could see between two lines parallel and a transversal because they don't share the same transversal anywhere. And so this is just not possible. Okay, well, let's look at the next example. We're told here that the measure of angle 8 plus the measure of angle 13 equals 180, which means that angle 8 and angle 13 are supplementary. Let's find angle 8. Well, here's angle 8, and here's angle 13. All right, so if they are supplementary, they equal 180 degrees. And if I'm thinking, okay, well, maybe this L and M are parallel lines, and that would mean that B would be the transversal. And they're both into the interior of lines L and line M. And they're on the same side of the transversal, B. So, hey, I think that's probably consecutive interior angle converse would prove that L is parallel to M by using the consecutive interior angle converse theorem. And what does the consecutive interior angle converse theorem say? If two lines in a plane are cut by a transversal, okay, my transversal is B, my two lines are L and M. So the pair of consecutive interior angles, okay, 8 and 13 would be consecutive interior angles in that case. They're supplementary. I'm told they're supplementary. Hey, then the lines are parallel. All right, we've proved it. All right, one more. All right, so this time we're looking at angle 8 and 6. All right, there's 8 and there's 6. Ooh, those look like vertical angles, don't they? Okay, but does that prove anything's parallel? If they're vertical angles to line L, let's say, cut by a transversal of B, well, I'm not able to consider any two lines being parallel. I don't have a second line to be parallel. It's not A. I can't use line A and B with L as a transversal. That doesn't tell me anything. And I can't look at B as being the transversal to lines L and M. Well, you know what? It's just not possible. I don't have two lines that could be parallel because I just got line L being cut by transversal of B, or I could look at it the opposite way. Then I got line B being cut by the transversal L. Either way, I don't have two lines that could be parallel. Boom, not possible. All right. You got to twist things around. You got to look, okay, what are my two lines that might be parallel? What would be the transversal? What's the angle relationship between those? And if that's the case, could I use the converse of the corresponding angles postulate? Or might I be able to use the alternate exterior angles converse theorem, or the consecutive interior angles converse theorem, or the alternate interior angles converse theorem, or maybe even the perpendicular transversal converse? I just love it.